us. We have CESMII here this year. John Dyck, John Wise. They were gracious enough to participate. I reached out to them and said, we really love to have you guys here. Standards are becoming more and more important in the world of unified namespace. And they have built a very large collaborative team that's going to do a breakneck presentation over the next hour. One that is probably the second most important presentation you're going to see here. Okay? So with that, John Dyck, John Wise, welcome CESMII, gang.
Thank you. Appreciate it. Well, good morning.
Morning.
So my name is John Dyck. I'm the Chief Executive Officer of CESMII, the Smart Manufacturing Institute, and as of this week, a finalist, not a winner, but a finalist in the Manufacturing Dumpster Fire Awards for shutting down a Kellogg's cornflake plant, which is a really, really bad thing to do. But anyway, so that's my bit of my story. Jonathan.
I'm Jonathan Wise. I'm the Chief Technology Architect at CESMII. I haven't shut down any plants.
Yeah, so he's from the IT side.
Yeah,
I'm from the OT side. Right. Clearly, right? No, I'm just kidding. So Jonathan, tell the audience something about yourself that they don't know.
So you warned me you were going to do this, and I thought really hard about what I wanted to share. And since there's a lot of transparency at this event, I decided to share a fact I don't typically advertise. I don't hide it, but I don't advertise it. I don't have a degree. I went to a technical college in Canada. It wasn't degree granting. It was a good school. It took me 4 years to finish a 3-year diploma, and the rest is self-taught. It's about 25 years of kind of the school of hard knocks. I share this because at CESMII, we're often accused of having like academic and lofty ideas, and my college profs would laugh at that because I had none of those when I was learning this. CESMII's principles are applicable. They are not academic, they're not theoretical. They are things we've learned through our experience, through more than 50 CESMII-sponsored projects. The things we're going to share today, you need to know. They do apply to you. So John, tell us something we don't know about you.
Yeah, well, where do I start? Yeah, I can't go quite that deep. Actually, you know what? I went to the same college Jonathan did.
A few years ahead of him.
A few years ahead of him. You had to point that out?
Yeah.
I think it's
it was obvious.
Self-evident, yeah, all right. Anyway, so I went to the same community college, got a 3-year degree in electronics engineering technology, and have been privileged to, so that means 2 Canadians are on the stage.
That's right, yeah. The Canadians are everywhere.
Also American, for the record. Proud American. So anyway, glad to be here. That's enough about us. I'd like to talk to you a little bit about CESMII. We are a community, we're a consortia. We're funded by the federal government, which is kind of odd, but I'd like to think we're making good use of taxpayer funds. Really good use of taxpayer funds. We're not from the government, but we are here to help. We really are. And our mandate is to actually cut the cost and the time to implement smart manufacturing by 50%. That is literally the mandate we have from the federal government. Because frankly, the large manufacturers have deep pockets. They struggle. They find it more difficult than they ought to. Forget the small, medium guys, right? Most of the folks in the room here represent big companies and work with big companies. The small, medium manufacturers have no chance, right? So how can we leverage the work that we're doing here, drive down cost and complexity? We call that democratization, and raise the tide so that all the boats float higher. So that's who we are. The cool thing is, I would say over half of the companies, the vendors, systems integrators, manufacturers in this room are part of this community. And so I would urge, and will urge, the rest of you to join us. This is part of the collaborative effort, which we're not really good at as Americans, because we're pretty individualistic. A collaborative effort to do things that none of you can do on your own. We're very, very purposeful in saying, what problems can we solve, and use your taxpayer funds to solve that are problems that you can't solve as individual stakeholders. So anyway, that's who we are. So believe it or not, this kind of nasty looking trend is Federal Reserve data on manufacturing productivity. I heard Walker and Jeff Winter speak on Monday about the sort of massive value creation potential in front of us with AI. Looking at this chart, can you tell me when, just intuitively, when Industry 4.0 was launched, right where it flattened, right? So those are maybe coincident. I think there are many complex reasons for why manufacturing productivity kind of plateaued and began declining around 2010. But the $10 trillion of value, my point is the $10 trillion of value creation did not materialize. And I think we're on the cusp of making the same mistakes, but you'll see through the conversation we're gonna have here and the things that Walker and community, CESMII and community are working on is literally going to impact this productivity curve if we can solve the problems that we're here to solve. So no pressure, folks. We're doing some really, really important work. I'm gonna close this tab. So put your thinking caps on for just a moment. As we think about sort of changing the curve, what is the most important invention in our careers? I'll say my career, because there's a lot of folks that are maybe not around when this happened. What's the most important invention that changed the way OT data was used to create value, period, over the last 3 decades? Well, I'm gonna spoil this for you. Anybody in the room here when Wonderware and Windows 3.1 sort of launched InTouch? There's way too many of you here. Yeah, all right. Yeah, so we believe, and this was recorded in 640 by 480, understandably, so it's a little grainy, but the point is, these folks and then the fast followers, they took this idea of democratizing OT data. So anybody with a 286, 386 PC and a $5,000 software product could now solve problems on the shop floor, right? This is absolutely revolutionary, and I would contend that there hasn't been a single sort of on that same level, a single invention that's created the sort of value creation trajectory that we did back then. By the way, I was selling Control-V for DOS at Rockwell. Windows wasn't deterministic. It was never going to work on the shop floor, was it? So anyway, we drank the Kool-Aid until we had a Windows 3.1 product, and then it was awesome, right? So anyway, what's constraining the next major wave of productivity here? I need to move on here. I'm gonna throw a scenario in front of you, which is kind of what we would say is the Industry 3.0 way, which both, by the way, I think most, Walker said, we're kind of rooted in Industry 4.0. I would push back a little bit, especially with the broader lens of small, medium manufacturers, and say that we're still firmly stuck in Industry 3.0 for most of manufacturing, because, you know, if I had more time on the stage, I'd speak to that. But so let's take this actual manufacturer, big automotive stamping shop near Detroit. Hypothetical situation, but in 2021, they decide we need to revamp our HMI SCADA and some of our manufacturing productivity KPIs. We're gonna select inductive, and we're gonna hire a systems integrator, implement an awesome new solution for our stamping facility. Next year, 2022 rolls along, Siemens, another systems integrator, solve an awesome, important quality problem. 2023 comes along, HiByte is selected along with some in-house production scheduling resources and another systems integrator, and they build an awesome production scheduling solution. In 2024, they select Flow and another systems integrator to do some important analytics and reporting. And then, of course, last year, they selected AWS to do some important data lake, enterprise data foundations work. And what the heck did they create? At the end of the day, and this is the hallmark of Industry 3.0, no standardization for any of that, no reusability, no portability, no economies of scale. Every systems integrator sat down in front of their platform, built everything from scratch, from bottom to top, right? And of course, vendor lock-in. We're gonna demonstrate here a really, really important approach with these same vendors and a few others that absolutely blow this away, and in fact, specifically address these massive constraints that are getting in the way of reducing cost and complexity. So we all heard, as I mentioned, Walker's comments about the fourth industrial revolution. The average Fortune 1000 manufacturer today has at least 50 mission-critical manufacturing systems that manufacturing IT supports, right? So they're all data silos, they're all stovepipe architectures. But behind the scenes in the plants, there's another, on average, over 1,000 shadow IT systems that are mission critical to making plants work. What the heck have we done? Those of you that have been around as long as I have, it's kind of, with no malicious intent, we're the ones that created these proprietary systems focused on building stovepipe architectures that would benefit us and drive vendor lock-in for us. We have not yet crossed the chasm. And I think the things that we're focused on here today, collectively as this community, and I'm so grateful for the leadership and the folks in this room that are part of seeing this move forward, we have to enable true OT-IT convergence. We have to enable the environment for manufacturers and great innovative leaders and implementers to solve problems in a much more low-cost, low complexity way. And we believe that this chasm will be bridged when we can bring technology to add to the people and process components or strategies that great manufacturing companies have already done. They've been able to bring people together on the people side. They've been able to create the operating models and the shared objectives and goals on the process side, but we've had no center of gravity on the technology side. We've had no way to standardize. Great manufacturers have done that internally, but again, at their cost, with no economies of scale. How do you unify a namespace when everything is done within your firewall? And Jonathan and team will talk more about that. So that's pretty lofty. I'm supposed to stand down and not talk about lofty things. By the way, my original plan to talk about sort of what's unique about me, I've never stood in front of a crowd like this and talked without PowerPoint. That's my shtick. I just did that. But what you're seeing here is a story that's going to come to life. That's not about PowerPoint. It's real. It's tangible. And Jonathan and the work that he and his team have done will do an awesome job bringing that to shining the spotlight on that for you today. Thank you.
So this isn't PowerPoint. We constrained John because we wanted to keep it all code, but we do have to do just a couple slides. Walker cornered me yesterday, and he said, make sure that everybody understands what smart manufacturing profiles are. Smart manufacturing profiles are imperative number 1 of 3. I believe in Walker's rule of 3. This is the first and most foundational aspect of what we would call a smart manufacturing information platform. This is a payload I grabbed off the virtual factory. There's a slight difference between each of these payloads. Can anybody spot it? I left it kind of easy. Yeah, the percentage, right? One percentage is measured as an integer, the other is measured as a float. Which one's right? Both of them are right, or both of them are wrong? Without a set of rules that say this data should look like this, it's up to the interpreter. This could be a math problem. It's probably resolvable. But when I scale this across all of the data in my unified architecture, these problems get really big. When I want to pass data between pieces of software and there isn't a way to agree on what that data should look like before it's in motion, these problems get really big. In computer science, we call this type safety. If the data is not type safe, I have to code defensively. I have to defend against changes in the data that I can't predict because I don't have a type definition that governs that data. So what are smart manufacturing profiles? They are rules for defining your data. We chose a specific language to do it, OPC UA node sets. That's part 5 of OPC UA. You don't have to use the rest of OPC UA in order to use an OPC UA profile. You can use OPC UA companion specifications, which are pre-made namespaces that expert groups have published for you based on standards. You can import those into a modern platform and use them to enforce the rules on your data. You can also make your own. You can share them with your community. You can keep them to yourselves. You just need the rules written down somewhere. If you are a vendor, there is no excuse in the age of Claude not to be able to import and export node sets. It's an XML format. It's a little ugly. It's hard to understand. Claude can eat it up in about 30 seconds. You're out of excuses. If you are an end user, I have a softer tone. I will accept UDTs. I will accept JSON schema. I will accept models, okay? But make the rules for your data independent of the movement of your data. This is MQTT Explorer. Everybody's familiar with it. This is not a namespace, this data that I'm looking at. I know that might come as a surprise to some of you. Hopefully it doesn't to others. This is an address space. In the address space, there is the implication that namespaces exist. I can see, especially as I look in a vendor section, I can see that somebody has put thought into what the data should look like. But I cannot, in the broker, see what those rules are. I can only see the effect of those rules. I need some pointer in the data that says, here's where to find the rules that govern this data. This is how we do data governance, this is how we apply internal standards, and this is how we can apply external standards. So, what are smart manufacturing profiles? They are the rules that govern your data. If you're a vendor, you need to do this all the way right. If you're an end user, you need to do the best you can with the tools that you have available, and you need to ask your vendors to do better. If you have done this well, then what you see in your address space are facts. This is the facts layer. These are true, verified pieces of information about your operation. But let's be clear, this is not a knowledge layer. Knowledge is the relationship between facts. When this temperature goes high, I have this quality problem. That's an explicit relationship that an AI might be able to infer, but there's a human somewhere in your operation that knows that information. A contextual manufacturing information platform is where I can gather that knowledge. I have to extract it from people's heads, and I need to articulate it somewhere that an AI can come along and find it. Jeff shared this great vision with us on Monday about what the future looks like. In order to get there, we have to capture the knowledge that our workforce has. And we have a burning platform. Todd called it the silver tsunami. We have a generation leaving the workforce that has this knowledge trapped in their heads. And right now, we don't have great tools to capture that knowledge. It's starting to happen. Our industry, as usual, is behind where everyone else is. But if you're on Inductive's Ignition platform, there's a vendor here called Thread that is building a knowledge graph on top of Ignition. If you haven't seen them yet, go check them out. You can build it yourself with something like Neo4j that gives you a graph database. But it doesn't have to be that hard. I found this on GitHub, and this captures knowledge in a Markdown document. Just capture the knowledge in a Markdown document. And we usually illustrate it like this. This is right on their GitHub. The data that I see in my address space that is governed by the type definitions that are in my namespaces that are verifiable and can be shared with my constituents, that data is an object. Those objects have relationships with other objects. The relationship lines are the knowledge that you need to capture. We don't have a lot of tools like this in our space, but they're coming. This weekend, we were on vacation last week. This weekend, I got a message from Sam Elsner at Litmus. He's like, I want you to check something out. Using a tool I'm going to share in a minute, a technology I'm going to share in a minute, Sam walked the hierarchy of the virtual factory and gave me this knowledge visualization. The hierarchical relationships in our broker are one set of relationships that represent knowledge about our systems. It's only one. We must not stop there, but we should begin harvesting what's there. This knowledge is there if we do a good job of creating our address spaces and govern them with namespaces. We need to start doing this. This is imperative number 2. Imperative number 3, then, is a problem CESMII spotted about 2 years ago. We get to work with good vendors who care about these things. But we observed that we were headed for a 3rd level of chaos. Chaos level 1 was communications. We have hundreds of different things we have to communicate with. We mostly solve that through an abstraction called drivers. Chaos level 2 is the namespace problem. Walker and community have been trying to solve that by unifying namespaces. Standards groups have been trying to solve that by publishing standards. We have a namespace chaos problem. We are headed towards an API chaos problem. If I organize all of this data in a system from vendor A, and somebody else organizes their data in a system from vendor B and C and on ad infinitum, what I end up with is a whole bunch of different open APIs that don't work together. If I'm an app developer, and let's be clear, the app is where the value is, right? The consumption of the data that turns it back into useful information or a decision or a recommendation or an AI, the app is where the value is. I have to write that app for each platform that my customers might want to support. This is API chaos, and we needed to get ahead of it. So in 2024, a small group of CESMII members got together and drafted an internet-style RFC. That's a request for comment. RFC is how the internet was born. And in November of 2024, we shared it with our community, including the vendors and end users, and said, this is what we think we need to do. We need to come up with a common API that all of the vendors can use. And I was not sure how people would respond. We got 2 responses from the vendor community. Only 2 kinds. Yes, we agree with you. Tell us how to do it, and we will do it. And yes, we agree with you. We passionately believe this needs to be done, and we will volunteer our time to make it happen. That group has been working for the past 13, 14 months. Some of the people you'd expect, they're in this room. Some of the people probably will never be in this room, but they contributed as well. Rockwell Automation contributed. And in fact, they're going to have an offering later this year that we can use. We call it i3X. It's Industrial Information Interoperability Exchange. It's just an acronym. But it is a common API. Before I dive into the details of that, which is the main thing we want to do today, I want to invite one of the leaders of this effort, Matthew Paris. You might know him from passionate and articulate posts on LinkedIn, deep conversations on Discord. He has been a leading voice in this effort, and he would like to tell us a story about i3X.
Hi, neighbor. I'm so glad you're here this morning. You know, I was thinking about something today. Have you ever tried to build something with your friends, but each had a different idea on how to do it? Maybe you wanted to use wooden blocks, and your friend wanted to use plastic bricks, and another friend, maybe some cardboard boxes. It can feel frustrating when you're trying to build something, can't it? Well, grown-ups can feel frustrated too. Especially grown-ups called engineers. I brought a story with me this morning that I'd like to share with you. It's about an engineer who works in a factory who's trying to build something. Let's use our imagination and hear how this engineer works with his friends. It's called Oh, the Standards You'll Meet. This is dedicated to my wife and children, by the way. An engineer, Ned, had to build a new app with plenty of snap and a plant data zap. With dozens of sources, each swearing its way, Ned fought every system all night and all day. The plumbing was finished, the data ran through, but he'd no fuel left for what apps ought to do. To the vendors, Ned marched in a terrible plight, and he said, I can't do this, not night after night. Don't hand me a menu of 42 stews, just pick out the standard a sane man would choose. The vendor replied with a, here we go grin. Well, how do you need all the data that you're in? Do you want it in tables and tags in a stream, in batches and blobs in a curly brace scheme? Ned gave them a frown. If you won't help me choose, I'll go hunt for the one interface I can use. At the topic talk post in MQTT place, where messages whizzed at a zip-zippy pace. Just publish, they cried. You can ship it in fling. Our mailbags are speedy. We deliver anything. Ned said, that is splendid, but what's in each sack? They just shrugged. Just subscribe. You can sort it out back. The mail flew like lightning at such a fast rate, but no one knew topics or knew current state. Then Sparkplug stepped in with the tool belt and gleam. I will fix topic talk. I'll refine every scheme. He built a strict vault out of node and device and squeezed every bit through a protobuf vice. Ned asked for one metric, a single small PSI. But a birthstorm of data rained down from the sky. Machines have their logic, but apps need their own. I'll find a new landscape where options are known. On a lawn stood a castle of OPC UA, where the users and vendors would buzz all the day. The guards in blue helmets were puffed up with pride. From the binary court, turn to left or to right. And Ned asked, what's the minimum I must support? Whoomp came out the options, a doorstop report. The ramp to HTTP wing was all soap, and Ned slitty slopped back. HTTP had no hope. He saw stones that were carved. You can build it your own. But to heave and to hove for a cell all alone? I will stay in the court. I'll learn binary in time. They all cheered standardized in their usual rhyme. Till a cloud rolled in over and slurped up the glee. That binary standard means nothing to me. Ned turned to the guards on a cloud-seeking quest. For cloud, they advised, use HTTP REST. Then he stumbled out tired in search of some rest. At the HTTP hotel, standard rooms, they professed. Every mat said /API, so quaint and so neat, but in every room was a different defeat. In room get, there's a bed, bolted up on the wall. In room post, there's no beds, no blankets at all. Must I scribble a spec just to get me some rest? There are 14 already, my 15th is best. Then up from the dust came a traveler gray who pointed his hand to a road far away. Go find that worn band. They were tired of the mess of protocols failing the market's true test. They took existing parts that are proven and true, but linked them in ways that are fresh and are new. To fix the connection and lighten your load, take the path of i3X. It's the app-centric road. Ned found the whole band cheering paths they would map. Discover the namespaces powering your app. Explore all the types and the things they were for. Query what's now and what happened before. Update what you can. Then you sync it once more. Subscribe to the changes. Don't pull anymore. Now hold here, Jonathan. So Ned hurried back to the chipper old stand to the vendors with all those menus in hand. He asked, will you travel this i3X road? They skimmed it and gasped. What a weight off our load. If we use these 5 verbs, then the custom work ends. We won't have to build 42 different blends. Then another called out. You can count us in 2. It's better for us, and it's better for you. And his shoulders unknotted at once with a snap. With no glue code to babysit. More time for the app. As he tipped back his hard hat and grinned a wide grin, like a door that was stuck, which at last let him in. In the depths of his bones, he felt everything align, from the duct tape of 3 to a 4.0 design. Wake up, Ned, barked his boss. We will need this app soon. And Ned blinked at his screens. It was late afternoon. As his boss walked away, Ned sat looking about. Was this whole journey a dream? We're about to find out. That engineer Ned from the story, thank you. That engineer Ned from the story you heard, it's not fiction. It's me, as you likely inferred. Last year on this stage, I gave a challenge to all. One way for app data. CESMII answered that call. Without lame excuses, blaming chickens or eggs, just steered this movement, running on its own legs. Well, enough of my blabbing. I am pleased to present all the vendors making it real with steady intent. With Inductive and HighByte and AWS to show, with Siemens and history brought here by Flow. With Ace Technologies bringing a data app browser in tow.
Thank you, Matt.
Is this a dream? Is this a dream? No, this is ProveIt. Cue the demo. Let's go.
Before I cue the demo, a little bit of a more technical explainer, as much as Dr. Seuss is awesome. As we looked across the 50 projects that we funded, we kind of analyzed what functions they needed. And this kind of became the thesis. We looked at the vendor community, and it turns out most of them already had these functions. They just had different ways to call them. So the theory was, you can keep your own API. There's always going to be things that are unique about your product. But if we can unify this kind of 80-20 rule, this 80% is what most people need. The 20% is unique to your product. We started working together, meeting twice a month to build a prototype. We considered a couple first-class data sources. So MQTT is obviously important. OPC UAs thought deeply about this, so we didn't want to ignore what they'd learned. But we need other sources of data, not just live data. We need historical data, and we need to make sure that you can plug in any other data source. However you build your back end, what's behind the API, you need to be able to expose this capability. I need to be able to explore what's in the address space. I need to be able to understand what types, what namespaces are present. I need to be able to get history, and I need to be able to get live data, and I need to be able to do this from a common user interface, or common programmer's interface. With a single data source, you cannot fulfill all of i3X. If you have MQTT, you can fulfill the live data stuff. But you can make that transparent to the application developer by adding an at-rest data source, a historian that does fulfill the history interfaces. All this requires is that your namespace is unified across your back end. This is the point of this effort, is so that once we've unified, we can get at all of the different kinds of data. I need types to unify. I need namespace rules. So you might plug in CESMII Smart Manufacturing Profiles. And to add capabilities like Sam showed us in that visualization, I'm going to need to gather some of the MQTT data so that we can find those relationships. So you can plug together an architecture that supplies the pieces you need in order to fulfill the API. Or you can work with your favorite vendor who is already in the process of supporting this API. And that's what we would like to show today. I've been asked to make it clear that this is hot off the presses. While we have been working together, changing products is hard. So this is a real ProveIt demo. We're going to do our best to prove it. But these are all like brand new pieces that are just coming together. So please be patient with us. The first thing that we needed was a common client. We are progressing towards a firm specification, but for now we need a reference client so that everybody can test against to make sure this truly is interoperable. For that, we built something called i3X Explorer, and I'd like to invite Craig Egan to the stage to tell us a little bit about that common client. Hey, Craig.
Thank you, Jonathan. So my wife says walking with a stick makes me look wise.
Wise. There you
Yes, like Yoda. And so I thought about that because I don't know if I want to look like Yoda when I'm old. So after last night's presentation, after the events, I thought,
You got to talk into the microphone.
oh, thank you. Wow, look at that. I thought maybe I should bring my joust and say, I3X, victory now. So I'm Craig Egan, ACE Technologies founder and chief engineer. You saw a lot of really neat things about i3X, so I think you understand the i3X concept. Let's talk about i3X Explorer. You're all familiar with MQTT and MQTT Explorer. So imagine i3X Explorer being the MQTT Explorer on steroids that's going to expose all the crazy things that Dr. Seuss and Jonathan here claim. So to start with, where do you get our i3X Explorer? You can go to www.acetechnologies.net. Jonathan here is driving for me because I've got no hands here, and I've heard that he is a great button pusher. He's been doing it most of his career. So i3X Explorer is available for download, cross-platform. It is obviously free of charge. If you would like, you can go to our GitHub repo. There you go. I'm ahead of the game here.
There's GitHub.
There you go. So all the source code's available. You can check out our release notes, and most importantly, contribute, right? Do we have any pull requests active right now?
Yeah, Graham submitted one. He found a bug leading up to this week.
Oh,
We'll merge that after the event.
there you go. Excellent. Well, that's the whole idea. This is our tool to use collaboratively. So we encourage you to participate unless you're a bad coder, and then just use Claude like everyone else, and that's just fine. So let's actually get into the real demo because the important people need to show this stuff. So with i3X Explorer, the first thing you do is point to an endpoint. So Jonathan, why don't you pick me a nice endpoint here?
All right, so this one's running on localhost, but it's wrapping a portion of the virtual factory broker.
Excellent. Okay, so once he makes the connection, magically, we're discovering namespaces and objects and hierarchy. But right away, I see a problem. It does not look like, I don't think we've got an SM profile applied here, do we?
That's right. This portion of the broker, nobody's applied a profile, so all we can do is infer a single namespace called MQTT.
That makes Jonathan very sad.
Yes, it does.
So we've got data, that's great, but it's like getting the IKEA desk without the instruction manual. So I can browse the hierarchy, I can get my data, but I'm missing half the piece. Half the puzzle's missing. So let's disconnect and try again.
All right, so this is pointing at the whole ProveIt broker, and you will have seen a number of vendors make an attempt to apply a smart manufacturing profile to their payloads.
And wow, look at that. So Dylan, I believe, made Jonathan very, very happy, right? Look, I see classes, I see objects, I see instances. I've got my user's manual, right, in layman's terms, for my data. I can still browse my hierarchy, I can get my data, but this is the missing piece. Notice as he's also browsing the hierarchy, we're also seeing a really interesting relationship graph. So we're seeing that, and we're also seeing our live data. And in future demonstrations, you're also going to see the historical data. So look what we've got in one single pane of glass. We've got the hierarchy, we've got the live data, we have the historical data, and for once, the user's manual. We have it all together for the first time. That's pretty darn exciting.
Yeah, I'm going to take a second here just to give a few more props. So Dylan did a great job. He implemented the machine basic building block for identification. I can tell that's Dylan because I see the type, and I can see the instances are in the Able Era topic branch.
Ooh.
Nice job, Dylan. Dylan's not the only one. This compressor, JPI, standardized this according to the compressed air companion specification. So they used published standard. And I can see right here directly from the virtual factory that they've applied a namespace, and I know where the rules are that govern this data. There's a couple others that did it by proposing their own profiles, which is a valid approach. That's how we work together. Dados, I know Eucadine did it. I know Skellig did it. So I can tell right away.
Who did their homework?
Yeah, they built their own,
right.
but they posted the GitHub link as the namespace URI. So this is where I can go find the rules that govern this data. This is how I can validate the data, how I can share that contract with other constituents so they know what to expect and they know when things are going wrong.
Wow, that's the real deal. That's the real deal. So we're going to have to figure out, what are we going to do with all this i3X? Well, I need endpoints in the shop floor in my applications. So, I don't know, maybe a good place to start might be HMI SCADA. I know a guy who knows a little bit about HMI SCADA. He is way smarter than me, but he is nowhere near as good looking. And I will hand the microphone over to my friend Travis.
All right. All right, well, thank you for that. So we're going to start at the low level. We're going to connect to our controllers, and we're going to basically build UDTs in Ignition, or bring in more smart manufacturing profiles that we can get out there and expose through i3X. So here I've got an Ignition Designer open, and I already have a bunch of UDTs that we built out for our ProveIt demonstration. And these UDTs are ones that we just defined inside of Ignition. And I've got all sorts of tags that are coming in here that we're putting in the virtual factory, as well as the ones that are already out there. And so with that, I'll come back to Designer in a minute, but let's go down to i3X. We're going to go to our endpoint within Ignition. Ignition is running in the cloud right now. We have the i3X endpoint on there. We're going to go ahead and connect to it. And we're going to be able to discover all of the namespaces that are in there. And in fact, here are all the Ignition UDTs that are part of our demo that we created. Now, that's the Ignition UDT namespace. Of course, we have the machinery, the machine identification type namespace as well. And you can see all the machine IDs that happen to be there. All right, so then that's great. Let's look at the data. If we go down to hierarchy, we're going to be able to see, if I come down to our MQTT engine, ProveIt 2026, inductive, go down to site 1. Let's go to liquid processing, tank storage. You can see all the relationships that are being built out in here. If I come down tank 1, look at process, I'm going to be able to see the live data as well as the history of that particular UDT. Now, we're also be able to expose not just parent-child relationships, but we can build any kind of relationship within this. And in Ignition, we decided to also bring in the alarms as a has-alarm relationship. And so I can see on this process, I have an alarm there, and I can get all the alarm information, including the history of those alarms. So it's a great way to be able to expose the full, true power of the tag system that is inside of Ignition. But we don't want to just be able to make everything custom, all the UDTs. We want to be able to follow the smart manufacturing profiles. And so for that, I'm going to go over here. We have built a converter that allows us to go browse cloud libraries, or if a company has their own smart manufacturing profile library, where we can then bring in new profiles, have them instantiate them, map them to our PLCs, and ultimately get them exposed in that namespace. So here we're going to go to our CNC-based profile that the CESMII members have created. I'm going to go ahead and import this profile. And what we're doing is basically going and downloading the node set that Jonathan talked about. It's an XML document. We're bringing it in. We're parsing that. And we're actually building out all the UDT objects that are part of it. This is a pretty extensive profile. There's a lot of different subtypes that are in here. So I'm going to just kind of go through and save these. What this is basically is if you have multiple instances of various objects, I can specify how many of them I have. So for example, I am going to do 3 axes, and I only have 1 second. All right, there we go. It's hard to hold the mic and do that at the same time. I'm going to go ahead and save 3 axes, do our channel, do our spindle, and then now I'm going to be able to import this into Ignition. So before I import it, I don't have any of those UDT definitions in here. So let's go down, import all those UDTs, and there they are. There is our CNC-based type. But now we have to instantiate that and map that to our PLC. I'm gonna go ahead and go to our profiles. We're gonna do a CNC-based type. We're gonna create a new one. And again, here, I'm gonna put this down just for a second. I need Jonathan up here too. So I am now mapping that to a PLC called CNC, and inside that there's CNC1. All right, there we go. There is our CNC machine. Let's go down to our axis list. Axis, you can see that data's coming through. There's our motor. I've got all this new namespace, all these new UDTs in there. What's the power of i3X, Jonathan? We get to see all that and expose that to others. So let's go now back to our i3X Explorer. We do have one bug. We're going to fix this bug, but I have to disconnect and reconnect to see that brand new thing that came in there. It doesn't refresh automatically. So let's go ahead and disconnect, reconnect, go to namespaces. Oh, look at this, profile CNC. And there's all of the beautiful types that are part of that. If I come down to hierarchy, not only do I have MQTT engine, but now I got the default. Let's go down to here and look at CNC1, axis Y, motor, and there's all the data coming through. It is literally as simple as that. All right, from there, we got to go further, right? There's many layers of the supply chain that we have to go through. Let's talk about how we can then take that data and go further with history.
Thank you, Travis. Good morning, everyone. I'm Graham Welton from Flow Software. We produce the time-based historian. If you don't know the time-based historian, well, it's a high-performance, reliable, and easy-to-use historian. Sorry. And what is unique about the historian? Free. There we go. Thank you, Orca. So why is it free? Well, we believe that the storage of your time series data should not be the barrier to gaining value and insight out of that data. And that's why we've made it free. So for those of you who have been using the historian, and we've got about 4,000 installations over the last year, for those of you that have provided feedback, we want to say thank you very much. With every release, we try really hard to improve the performance, improve that reliability, and make it easier to implement and set up. And because of that, we've actually got systems running today that have 1 million tags at 200,000 data writes per second. 1 million tags, 200,000 data writes per second. Apart from performance and reliability and ease of use, one of the things that we really drive hard for with all of our products is an open architecture. So with all of our products, we wrap a industry standard REST API around all the functionality, whether it's configuration, data ingress, data querying, whatever it may be, so that you can build your tooling around that. So when CESMII introduced i3X, this was no stretch for us. This was a natural extension of what we already do. Not only our philosophy, but our implementation. And so I'm very pleased to announce that as of today, you can go and download version 1.3.1, and it's got i3X API baked right into the free historian. One more, there we go, thank you. Okay, where's that tab? All right, so here we have the historian administrative UI. I'm not going to spend time on this. Just very quickly, we go into the CESMII dataset. Here you can see all the tags in that dataset. This is coming directly from the virtual factory. You can see the last value, you can see the unit of measure, you can see additional fields. All of this is coming from the virtual factory. If I go to the API, you're going to see our documentation. This is our standard API. I'm not going to spend time on this, but let me show you. We've now got our i3X definition. And there you will see all the endpoints, the explore endpoints, where you can discover the object types, the objects, the query endpoints, where you can go and get the last known value, as well as the history, and then, of course, the subscribe endpoints. So let's go and see what that looks like here. Oops. There we go. Connect to that. This is our historian that's running in the cloud. You'll see Jeff and Lenny using that later today. And let's just go and browse some data. Sorry, wrong one. I'm going to drill down into some data that we're actually getting from the virtual factory. Let's just pick an example. Which one's got data? Sorry, I'm not. Dallas doesn't have data. There we go. All right, so we can see the last known value up here. We can see the history, about an hour of data by default. And if this is updating, we can actually go and subscribe to that as well. I think the data points are coming in every 5 seconds. So this is coming directly from the virtual factory into the time-based historian, and then through i3X API. And so all of this data has actually been, you'll see from the virtual factory, it's actually been pre-modeled and pre-structured, and that's because we're using HiByte's data source. So I'll hand over to Aaron.
Thanks, Graham. Is this plugged in? Are we sure? Before I even get on this thing, is it plugged in? All right. It is a Mac, so we're going to have to struggle through that together. Not a Mac. Thank you for the support. So I was one of the guys that saw the RFC that Jonathan posted and was like, I love this, I support this, and this is wrong, and this is wrong, and this is wrong, and this is wrong. Because I'm an engineer, so when I see Swiss cheese, I just see the holes, right? And that's how I got involved. And now I'm in a group chat on Teams with Jonathan and Matt, and I think we have like 100 messages a day back often on i3X just trying to get the spec right. So we need help on the spec. That's my call out there. But my name is Aaron Semley, CTO of HiByte, so we're industrial data ops, right? And I often talk about industrial data ops as the API of the factory. So when an actual API standard came along to represent that, like hugely supportive of that. So I'll show you briefly, in the means of time here, how we do that in HiByte. So everything I'm showing you is in alpha. If you want a version of that, we can send it to you. It'll be in our next release. Know that anything you see up here is going to break because we are working on the spec. So play with it, don't put it in production, but things are going to change as we learn and open the standard. So you'll see here is this is HiByte. We're deployed at the edge inside the factory. This is a little i3X services tab where we're really just enabling the i3X functionality. If you go into our namespaces, so what we're doing is we're connecting to everything that's in the factory, driving that through contextualization and modeling, right, and then making that available through namespaces. And those model definitions are here, and I have to do that. Jonathan mentioned this. We do support this. I don't have this prep for the demo, but you can come in and import a model that is a node set, go and select the files on this. Oh, geez, this is Mac, huh? I'm not going to do it. I can get out though. And those models would appear, and you would hydrate those models in HiByte like you would anything else. So what we do, we have this view of the factory we built with Boston, Seattle, and Dallas. And I'm sorry, Graham, Boston was the only one with live data, but you nailed that. That's actually coming from the ProveIt factory. And what I'll do now is just jump into i3X and show you what that looks like on the i3X side. So if I can remember the IP this time. And we have the same bug that Travis had mentioned. I actually fixed it yesterday with a refresh. I'm not going to show that, but I think that is going to be a common issue of trying to refresh the address space.
My mic, no, and real quick, we're not going to do a Q&A. However, they are doing a workshop at noon in room A. Jonathan Wise will be down there, so if you have any questions, because they're going to go 5 minutes over, we're not going to do a Q&A. Room A at noon.
Okay, I'll speed this up then as well, so others have. So these are the model definitions as you saw, right? These are high-byte models. This is the same, under the hierarchy, you see the same namespace you saw on the product. And in here, you can bury down, and I'm going to go down to Boston sub-asset here, and you see the data. And what's really cool is you see the live data. I could subscribe as well. This historical data is actually coming back from Timebase, so I'll just briefly show you under the hood there. I've got a pipeline in high-byte, single pipeline, and this is simply being called by i3X, reading the Timebase historian raw data, running it back through the model, so we deliver it through i3X contextualize. And Graham sent me that last night, wired it up, and there we go. So it just shows you the interoperability of the standard. And with that, I'll hand it off to Scott at AWS. We're sending all of this to SiteWise up in the cloud, and he'll show you what that looks like up in AWS.
Thank you, Aaron. Let's see.
This is important, so don't feel rushed. We have until 15 after. It's an important presentation. But try to be done in 4 minutes.
Okay, let me get connected first.
So if you're a vendor in here, and you develop software products at an absolute minimum, and you're not having a conversation with CESMII and this working group, you're making a mistake. Rest assured.
Okay, so what high-byte has pushed all of their namespace up into AWS IoT SiteWise. SiteWise is our time series data store, has modeling, has a hierarchical relationship. And so let me show you what that looks like first in SiteWise. Same information that you saw in the namespace from high-byte. And I can drill down through that hierarchy and get down to the actual measurement points within SiteWise. If I go down through this structure, I get down to the asset level where the actual measurements are defined. SiteWise also includes built-in anomaly detection, also has the ability to do calculations through what we call transforms and metrics on that data, propagate those values up through that hierarchy. If I take if I go into actually the measurements, these are actually all of the values that are coming in real time. Let me go back now to Explorer, and now I'll be able to drill down through that identical hierarchy. It will look exactly the same. I can go all the way down, and I know that there's live data in Boston now. If I go down through here, I'll get all of the measurement values. And if I go down to grab one of those values, I get that same historical information. I'm now pulling that history out of SiteWise through SiteWise API. And I can also go in and subscribe to that information. I need to set polling. And again, we're on a 5-second update from high-byte. I'll be able to subscribe to that information. I could drop additional values in there for that subscription. So same visualization, same client against SiteWise, and then populated initially by high-byte.
Thanks, Scott. I'm Todd Malone. I'm a bit of a SCADA HMI historian. I started off on DOS. So yes, there were DOS HMI systems. By the way, we called them MMI, man-machine interface in those days. Sorry, ladies. What we've seen here is each of these guys has been pushing data up into the system. And it, of course, is available. But the question is, how do we tie together all of these different vendors? How do we look at that information in such a way that we can do things with it? So let me see if I can pop up this part. And so what ends up happening is we end up with supply chain. Interesting things start happening in the supply chain. You have different vendors, you may have different sites, you may have different things going on. You need to pull that together in such a way that you can see the data and get some information. There's always those questions about what's the schedule look like? Are we going to be able to deliver in time? Can we get the packaging stuff pulled together so that we can actually deliver to the end user those kinds of products? And so what we're seeing is the i3X delivering that interoperability to give us the visibility across multiple stations like that. So let's take a look and see what's happening here. This is Mendix by Siemens. It's an AI-enabled, low-code, enterprise-level app. So the low-code part is writing back to the system, so you always have to touch a few things. But let's take a look and see what's happening in our production schedule. So this i3X enabled product now is taking a look at the different batches that the different groups are providing to us. Now this is one line, and it's our bottling line, and we can see some details about that by going inside of here, and we can see so we have a scheduled end time. This one should be done today. Okay, no problem. And we're looking at the next one, and this batch looks like it's going to be done later today. Okay, that's good news for us. We take a look at our batch, Rutrow. We have a delay. So what's going to happen here? So here we have a delay. We can see that it's delayed. We can see some information about the bioreactor that may be putting that in place. And we have a delay, scheduled in time, now adjusted date. Oh no, that's 7 days in the future. We may not make our ability to pull that together. And so this information coming through that interoperability with the i3X gives you that visibility across the whole place. We'll probably need to call one of our vendors and see if we can get some more bottles in here because, oh, by the way, it was 12,000 and now it's 8,000. So some real problems there.
Thank you.
Thank you, Jonathan.
Thanks. I got to wrap up because we're at time. I'm going to ask Tony Huffman to come to the stage. He's an end user that's waiting to use this. But just to recap what you saw, all of these vendors are interoperating because they've unified the namespace and they're using the same API definition. Everything glues together smoothly. We literally put this together in weeks. There are developer tools, connect.cesmi.org/i3x, i3x.dev, on our GitHub. As of this week, we have an i3X Python client library. So if you've used Payho MQTT, you already know how to use i3X. This only works if people actually want to use it. So I'm really excited that Anthony's here to tell us how they want to use it.
Hey, everybody. I'm going to cut to the chase. I didn't write a children's book, but I'm going to jump through these slides pretty quick. Part of Georgia Pacific. We make toilet paper, paper towels. Brawny, check it out. It's 3-ply now. All right. How many guys have this in your factory? This is whiteboards and MES, Microsoft Excel spreadsheets all over the place. It's still everywhere, right? Why is that? Well, what we want to try to get to is a connected and augmented workforce. We want to make sure that we get the right information to the right people at the right time with intelligence. I'm going to talk about 5 things that I've seen that get in the way of this. These are kind of the secrets of success, if you will. I've done this over 20 years and over 20 factories, or over hundreds of factories, 20 years over 20 countries, that's what I meant to say. We've got a lot of efforts underway, and what I find is there's 5 things. One, you need a shared vision, and there's a difference between sharing a vision and having a shared vision. Sharing a vision is PowerPoints and posters. Having a shared vision is a collective understanding of what good looks like. It's a big difference. The second is talent. and in particular, the site leadership. That site leadership needs to be what I call bilingual. They need to understand discipline operations, lean manufacturing, but they also need to understand technology. It's very rare to find folks that know both, and so you're going to have to do some upskilling and development of that site leadership team. If they're not as passionate as you guys are, you're already dead in the water. The third is knowledge. We need to tamper our inner engineers and ask for help. There's a lot of people out here in this audience that have seen better practices. We need to apply those better practices. There's also groups you can lean on. We've got CESMII, we've got 4.0 Solutions, we've got a lot of different groups that we can partner with to get this right. There's already recipes out there. Don't reinvent it. You see that over and over again. The next is orchestration. So what I see in a lot of facilities is we've got siloed activities. We've got operational excellence people, process control people, other groups working in silos, not collaboratively towards that shared vision. You have to get people working in a way that is collaborative, but also in an order of operation. I do this, then this, then this, and this, and we work together. And then lastly is the measures and metrics, the rewards, the recognition, and the quick wins that you can showcase to keep the momentum going. I see far too often we get stuck. We try to do this big bang. We try to do way too much. And so for us, we're going to make a bet. We want to be an early adopter of i3X, so we're going to have a workshop next week to explore how we can take advantage of the technologies we already have with this new framework and innovation ability to partner with groups. And so we're going to not only do this across Georgia Pacific, but our plan is to roll it out across the wider Coke organization. So we have Molex that's also participating, and other organizations across Coke that are very interested. So wanted to just highlight those lessons learned, as well as give you a sense for our approach and next steps. Thanks, John.
Thank you, Tony. Tony doesn't just talk the talk, he walks the walk, and that's why it's awesome for him to be here and share this with us. If you haven't yet connected the dots, 30 seconds, Walker, I promise.
We've got 2 minutes and 40.
Oh, awesome. If you haven't yet connected the dots, if you're a domain expert, if you understand manufacturing, but you haven't ever built a product because the load is so heavy, the lift is so heavy, guess what? You can now, especially with this unbelievable set of AI tools we have, you can now build a product against an API, not against an entire stack. And by the way, all these great platform vendors can now fulfill that app versus being tied to one ecosystem or one vendor, one proprietary vendor. So
real quick, how many of you are going to download i3X Explorer? Okay. All right. And how many of you are going to be angry with the software vendor who doesn't allow you to view the data through i3X Explorer? All right.
yes,
All right.
love
there
it.
you go.
That's the last thing I was going to say. If you're a manufacturer here,
We're going to implement i3X after today.
that's the next question. Awesome.
Thank you.
Love it. If you're a manufacturer, you should absolutely never buy another data silo, never buy another stovepipe architecture. You need to demand, and this is the beauty of this community, Walker. Thank you. You are the catalyst. You are the visionary that drove this. You should not ever. We get to now work with you as vendors, as systems integrators, to drive this into the marketplace. And you have created the demand and the visibility to this and the importance of this. And that's why, Walker, we wanted to just express our gratitude for inviting us, for being gracious in actually providing the opportunity to have this platform here with you. So thank you.